Hey guys, welcome back to the channel. I'm Shashank S, a student from SBCE, and today in this video we'll be learning about CPSR, that is Current Program Status Register. So first we'll be going to the introduction part, then we'll be knowing what is CPSR exactly with its significance, then we'll be knowing the importance of usage of CPSR in ARM embedded system, and then we'll be going through some CPSR flags and what are all the processor modes used in it, what is interrupt handling, and at the last we'll be learning how this CPSR is optimized in ARM embedded system. So moving into the very introduction part to ARM embedded systems, so these ARM processors are widely used in embedded systems due to their low power consumption, high performance, and extensive ecosystem of development tools and software. This presentation will provide you an overview of the role of the CPSR in ARM-based embedded system design and development. What is CPSR? The CPSR is a crucial register that is used in these ARM processors which stores the current state of the processor, including their condition flags, interrupt enable or disable status, and even the current processor mode. This plays a central role in program execution and also interrupt handling. So, what is the significance of this CPSR usage in ARM embedded systems? The CPSR is a crucial component used in ARM-based embedded systems, providing essential information about the processor state and thereby enabling fine-grained control over its operation. So this register plays a pivotal role in various aspects of embedded system design and development, from interrupt handling to optimization. Importance of CPSR in ARM embedded systems. Execution control. The CPSR determines how the processor executes instruction and handles exceptions. Interrupt management. The CPSR's flag and mode bits are used to enable, disable, and also prioritize interrupts. Processor state tracking. The processor stores the current state of the processor, thereby allowing for efficient context switching. CPSR flags and their significance. First, we are having condition flags. So the CPR contains flags such as negative, carry, and overflow, which reflects the result of the last arithmetic or logical operation. Mode bits. The mode bits in the CPR determine the current processor mode such as user, system, supervisor, and interrupt modes. And at the last, we're having interrupt bits, which means the CPR includes bits to enable or disable interrupts, thereby allowing for precise control over interrupt handling. Accessing and modifying the CPSR. The very first step to access and modify the CPSR is to read it. That is, the CPSR can be read using specialized instructions like MRS, that is, move to register from special register. And the second step is to modify it. That is, this CPSR can be modified using instructions like MSR, that is, move to special register from a register. And at the last step, we're having conditional execution, which means ARM instructions can be conditionally executed based on the CPSR flags, thereby allowing them for efficient branching and flow control. CPSR and the processor modes in ARM embedded systems. User mode. The most common mode for executing application code is user mode, with limited access to system resources. Privileged modes. Supervisors, FIQ, IRQ, and abort modes provide access to system resources and interrupt handling. And at the third, we have system mode. That is the most privileged mode used for operating system code and low level hardware control. So at the last, we have CPSR configuration. That is, each mode has a dedicated CPSR configuration allowing for efficient context switching. CPSR and interrupt handling. Interrupt triggered. An interrupt causes the processor to save current CPSR and switch to an appropriate interrupt mode. CPSR flags updated. The CPSR flags are updated to reflect the interrupt state, enabling efficient interrupt processing. Interrupt handled. The interrupt services routine executes and the CPSR is restored to resume normal program execution. Optimizing CPSR usage in ARM embedded designs. Efficient handling. Carefully manage CPSR access and modification to minimize their performance impact. Optimize interrupts. Leverage CPSR flags and modes to optimize interrupt responses and latency. Hardware acceleration. Utilize the hardware assisted CPSR management features for improving efficiency. And yeah, that's all we have for today. If you guys found this video helpful, like and share it, and do subscribe to my channel. Thank you.